All right, we are going to continue on with our idea about the difference quotient. And so we've kind of touched on this already, but the difference quotient, also known as the definition of a limit or the limit definition of a derivative, okay, it looks something like this. The derivative of f of x equals, as the limit approaches 0, f of x plus h minus f of x all over h. And so again, this kind of will break it down into the equation is essentially the old slope equation, y2 minus y1 over x2 minus x1. That's the equation we've used for slope for years now. So again, f of x plus h represents your second term. F of x represents your first term. X is your first x, and x plus h is your second x. H represents the change in x. Fx plus h, so your numerator represents your change in y. And then the limit represents as we are approaching h of 0. So again, you can see how it kind of simplifies how if we start with our old equation and then we start inserting our x's and our h's, we see that we get left with an x minus an x, which cancels out, which is how we are left with our final equation. So again, how did we develop this? We developed it by going through these steps. So if we take the function 2x minus 4 squared plus 8, we can see that that's graphed in blue here. There are multiple secant lines. Here's one secant line. Here's the second secant line. Again, 2 points. And then we have one tangent line right here. So again, we took our two secant lines. They met at a point, and we want to find the tangent right here. So the slope of our tangent function is negative 1.5 x minus 3 plus 8.2. So let's take a look. As h gets smaller, so again, h is this down here. As h gets smaller, as h gets closer and closer, we find that the slope of the secant line gets closer to the slope of the tangent line. So if we want to find the slope as h approaches 0, we get the limit of the equation. So again, what's our process? We are given the function, okay? So let's take the function f of x equals 3x squared plus 6x minus 4. So that's given. Step 1, we're going to substitute x plus h into f of x. So basically, every time I see an x, I'm going to write x plus h. So I'm going to say f of x plus h equals 3x plus h squared plus 6x plus h minus 4. And now I can simplify. So x plus h times x plus h gives me x squared plus 2xh. I have to FOIL this out. Plus 6x plus 6h minus 4. We still need to now we need to distribute this. So again, this was the first step I did, and then I also substituted here. Now I'm going to take 3 and I'm going to multiply it into each term. 3x squared plus 6xh plus 3h squared plus 6x plus 6h minus 4. Now we can try to determine if there's anything that we can simplify or group together. And I notice I've got x's, and then I also have h's. So I'm going to have to think about, can I combine any like terms and sort of look to smush anything together. And so I'm going to kind of put my x's together, and I'm going to say, all right, let's take 3x squared plus 6x, and I'm also going to include this negative 4 here because I got to put it somewhere. And then I'm going to leave all my h's left over as well. 3h squared plus 6xh plus 6h. So just reordering how I push things together. And so now I'm going to use, so again, this is just pre-work. This is just getting ready. Now I'm going to use this formula to organize my numerator. So step 2 is to order your numerator like this. So again, if my numerator is f of x plus h minus f of x, I just found that my f of x plus h is this last step right here. So I'm going to rewrite. These do take up a lot of room. 3x squared plus 6x minus 4 plus 3h squared plus 6xh plus 6h. And then I still have to do minus f of x. So almost this whole thing is in another set of brackets. I almost needed to make it smaller. Oops. And then I'm going to make this into parentheses because it doesn't need to be brackets. And then I have to do minus f of x. Well, that's this function right here. So minus, and again, I have to keep my parentheses because this negative sign gets distributed. So that's my numerator. And now we can start to simplify. So again, remember that this gets distributed here, here, and here. We're going to add a page so we get more room. Sweet. All right, so I'm going to rewrite this in a different color just so we can see it. Negative 3x squared minus 6x plus 4. So let's find stuff that cancels out. 3x squared minus 3x squared. 6x minus 6x. Negative 4 plus 4. Okay, so this is all gone right here. So that means all I'm left with on top is 3h squared plus 6xh plus 6h. That's my numerator. Step 3 is to organize your numerator and denominator. So if we think back to the original equation, again, I still have divided by h over here. So I'm going to go ahead and set up basically my whole problem and say f of x plus h minus f of x all over h equals 3h squared plus 6xh plus 6h all over h. And so we can, again, realize everything we're trying to do is to factor out this h. So we get 3h plus 6x plus 6, and then all over 1. You don't need to necessarily write that. And our final step then is to evaluate the limit. So evaluate limit, which in this case was h approaches 0. So the limit as h approaches 0, what were we left with? 3h plus 6x plus 6. Again, if I were to plug in a 0 there, the limit as h approaches 0, that's going to just equal 0. So this is going to kind of zero out. 0 plus 6x plus 6. So my limit of the function is going to equal, or the slope of the line tangent is going to equal 6x plus 6. So the slope of my original function, we'll call it m, of the line tangent to f of x equals 6x plus 6. So I had to do all that work to get this final answer, 6x plus 6. All right, let's do a couple more examples here. Find and simplify the difference quotient. So again, I'm just going to write it right here. Limit as h approaches 0, f of x plus h minus f of x all over h. This is something you need to memorize, okay? You have to know how to set this up. Every time I see an x, I'm going to write x plus h. So 2x plus h plus 3 minus 2x plus 3 all over h. I'm going to start to simplify. Again, these may take up a lot of room. 2x plus 2h plus 3 minus 2x minus 3 all over h. What can I cancel out? Cancel, 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 cancel. 2h over h equals 2. Therefore, the difference quotient is going to equal 2 for part A. Let's look at B. Again, setting my problem up. I'm going to take x plus h squared plus or minus x squared all over h. I was bad. I should have wrote the limit. The limit as h approaches 0. So again, how do I get x plus h squared? That's x plus h times x plus h multiply. That's so big. Let's see here. Multiply, 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 multiply. I get x squared plus 2xh minus h, or plus h squared minus x squared all over h. What can we simplify? X and x. So we are left with 2xh plus h squared all over h. If you divide these out, this goes away and this goes away. You are just left with 2x plus h. And then as we look as h approaches 0, again, as h approaches 0, this is just going to equal 2x. So my final answer for this one is 2x. So kind of like the big idea in the difference quotient function, again, what we started with, h cannot equal 0 because you can't have a denominator of 0. However, an important question is, what does the value of the function become as h goes to 0? So if I think about the function g of x equals x squared, if I were to graph it, it's a classic parabola. When x is 1, y is 1. When x is 2, y is 4. And it's basically the same on the other side, but with a negative exponent. So again, maybe we make a table. We say x, y, negative 2, 4, negative 1, 1. We're talking about 0, 1, 1, and 2, 4. So again, as we approach from the left side, it's going towards 0. As we approach towards the right side, it's going towards 0. So the function as h goes to 0 is the limit is going to equal 0, but the function of 0 actually does not exist. So as we're looking at the limit, because it's approaching the left and the right side from the same from the same function. However, we said h can't equal 0, which is why we have to look at the limit. So the big point, the value of d of a as h approaches 0 is the slope of the line tangent to the curve. So you find that specific point, you plug in the slope, and you will find your answer.